Hi folks, we are back with this video of exercise 6.5, which is not getting over. It's a very voluminous exercise. Last time we finished the question number 4, so this time we'll be taking up the question number 5. Now in the question number 5, we have our concept is changing a little. All this time we were doing local maximum minima. So its procedure was different. We were doing the first derivative, we were doing the second derivative, we were trying to get the critical point, and then we were checking whether it's a maximum point or a minimum point and all. So, and then we were finding out the maximum minimum value. So the procedure was slightly different. Now in this question, that is this question number 5, they ask us to find out the absolute maximum minimum. So absolute maximum minimum is restricted to an interval. So its procedure is slightly different. So it I would say simpler than the local maximum minimum. So for this, we don't have to do much. Second derivative and all we don't require. We just have to find the first derivative, which helps us to get the critical point. And the moment you get the critical point, we just check the function's value at the endpoint of the intervals and the critical point. And then we decide which is the maximum point and which is the minimum point. So relatively very easy and not confusing at all. Very easy to do. But only thing in the exam, when you go for the exam, you have both absolute maximum minima and you have local maximum minima. So there is a tendency of getting confused between how to do which like that. So you have to be clear that by local maximum minimum, this is how the procedure, and absolute maximum minimum, this is the procedure. So if the procedure is clear, then we can do it quite easy. So that's what we're going to do right now. It's this question number 5, which is all about absolute maximum minima. You have to find out the absolute minimum, maximum minimum points, and also their values, as we did last time in the question 3. So let's proceed. The first question is f of x equal to x cube. So for this, and they give you the interval, that the interval is between closed interval minus 2 to 2. Yeah, closed interval minus 2 to 2. We need to check where is the absolute maximum minimum point. So as usual, our first step is going to be to find the first derivative and then equate the first derivative to 0 to get the critical point, and then check for values. Very simple actually. So let's first find out the first derivative. F dash x is going to be very easy, 3x squared. And then to find the critical point, let f dash x be equal to 0, which means 3x squared equal to 0. Let the 3 go on the other side as a division, which finally becomes 0. Makes your x squared becoming 0. So x becoming 0 in fact. So you get your critical point as 0. So that's it. So if you've got the critical point, we have to check the function's value at the critical point and the endpoints of the interval which is given here. And then decide which is the maximum minimum. So let's do that right away. First we will find out f at minus 2. So which is minus 2 the whole cube, which is minus 8, negative 8. And f at 2, which is 2 cube, which is positive 8. And also at the critical point, which is 0. So it is 0 cube, which is 0. Now it's from this value that we will decide which is the maximum and minimum. So out of these 3 values, this is the maximum value. And out of these 3, this is the minimum value. So your absolute maximum value is 8 and absolute minimum value is negative 8. And it happens at x equal to 2. Maximum happens at x equal to 2 and minimum happens at x equal to minus 2. This is the answer. So we say therefore absolute maximum value is 8 at x equal to 2 and absolute, I sometimes write ABS, but let's write absolute minimum value is negative 8 at x equal to minus 2. So that's your problem number, sub-question number 1. So we have many sub-questions. So I think we can take up 1 or 2 more sub-questions over here. So let's take the second sub-question, which is as usual a trigonometry question. You have f of x becoming sin x plus cos x when x takes the value between 0 and pi. Let's see it right away. We have the second question which says that f of x is sin x plus cos x. And they say that x takes the value between 0 and pi. That means they give us an interval between 0 and pi, closed interval, and they ask us to find out the absolute maximum and minimum value. So as usual, like as we did there, we'll take the first derivative, get the first derivative, equate it to 0 so that we can get the critical points, and from there, with the help of the endpoints, we will be finding out where is the maximum and minimum. So let's have this done. For the first time, let's have the derivative. We've done it a number of times before. That sin x plus cos x is going to be cos x minus sin x, and then we have f dash x becoming 0 because we need to find the critical point, that is cos x minus sin x equal to 0. That is by taking sin x on the other side, it is cos x equal to sin x. Cos x equal to sin x in between 0 and pi, that is in the first and second quadrant, can happen only at x equal to pi by 4 or 45. Nowhere else it happens. So this can happen when x equal to pi by 4 at 45. So that's a critical point. And then as usual, we just get the function's value. So we have function's value at 0. So that's good. Sin 0 plus cos 0, which is 1 because sin 0 is 0. So cos 0 is 1. And then we can take f at pi, which is sin pi plus cos pi. Sin pi we know is 0, but cos pi is negative 1. So also f at pi by 4. So that's going to be sin pi by 4 plus cos pi by 4, which is 1 over root 2 plus 1 over root 2. Denominators are equal to 2 over root 2, which is further root 2. Okay, so we have these three values, 1, negative 1 and root 2. We have to decide which is the smallest and which is the biggest. So negative 1 undoubtedly is a minimum value. Among 1 and root 2, root 2 is 1.414. So it is a maximum. So this is your maximum value. That's it. So your absolute maximum value is going to be root 2 at x equal to pi over 4, and the absolute minimum value is negative 1, and that happens at x equal to y. That's the concept of absolute maxima and minima. Very routine and very straightforward. Not much of a hassle, not like local maxima and minima, because there we had the second derivative. So, and then that procedure, sometimes it sinks in really fast, sometimes it takes time to sink. This is quite easy procedure. So, only thing, we shouldn't get confused between this and the local maxima minima. Then it's fine and comfortable. So, that's all for this video. I think we can have the later problems in the next video. So let's meet in the next video. Thank you.